Hey children, we are just going to quickly discuss a little bit more about slope from our discussion today in class. We're just looking again at what slope is. It's basically just rise over run. You see what I did there with my little word art? It's pretty cool, right? I know. Anyways, so let's have a look at a few more examples just to sort of define for us a bit more about the mystery that is slope. It's actually not a mystery, but whatever. All right, well, here we have two lines whose slopes are actually very similar, aren't they? Okay, and just to prove it to you, we can look at the rise and the run of both of these lines. And if you count here, this is a rise of 5 and a run of 7, just like the one over here. So they both have a rise of 5 and a run of 7, but it doesn't make sense that they have the same slope because they're sloping in different directions. And so the way that we sort of are, the way we do it is we say that if you read left to right, like most of us normally read, well, not most, I shouldn't say most of us, maybe most of us in this class, but maybe not most of the people in the world. And that's a whole philosophical discussion. Anyways, when we read left to right and we talk about sorry, I just lost my train of thought. Anyways, the slope is positive going up and to the right. In other words, I'm climbing the hill here going left to right. That's a positive slope versus going down a hill here, and that's a negative slope. Okay, so we can sort of think of it in this terms. Uphill is a positive slope, and then which would mean downhill would be a negative slope. Okay, so that's one easy way to differentiate positive and negative slopes. But the good thing is it doesn't matter which way you read slopes. If you calculate slope the same way all the time, it'll always be the right sign. Let me show you what I'm talking about here. Okay, so here are two lines and two line segments, I should say. We're going to calculate the slope of both of them, and we're expecting the one on the left to be positive. What we said was to calculate slope, it is the change in y divided by the change in x. Or in other words, you take one y coordinate, I'm just calling it y2, and you subtract y1. Okay, so find the difference between the two different y coordinates. Or you, or sorry, and then on the bottom you do x2 minus x1. Okay, the order actually doesn't really matter. I can do y1 minus y2 because it's arbitrary. I can pick whatever I want to be y1 and y2. The important thing though is that you do the same order for top and bottom. Okay? In other words, don't do this. If I do y2 minus y1 on top, I can't do x1 minus x2 in the bottom. That's going to give me the wrong answer. It's very bad. So let's take that first line and just plug in some numbers here. And let's just let's call this point up here 1. Let's call this point down there 2. Okay, I'm just going to fill in y2 and y1. So the y coordinate from point 2, so that's negative 3, minus the y coordinate from point 1, which is 5. Okay, over, and then the x coordinate from 2, so negative 5, minus the x coordinate from 1, which is negative 1. All right? Okay, and then that's going to give me, well, negative 3 minus 5 is negative 8. And negative 5 minus negative 1 is the same as negative 5 plus 1, so that's negative 4. In other words, the slope is negative 8 divided by negative 4 is positive 2. All right? But now let's, instead of doing it that way, let's switch it around and see what happens. Okay, so now we have the point switch around. So the other one is 1, and the top one is 2 there. We're going to do the same thing. So y2, so 5, minus y1, so negative 3, okay, over, and then now x2, so that's going to be negative 1, minus x1, negative 5, okay, and let's add those. Well, 5 minus negative 3 is positive 8, because it's 5 plus 3. And negative 1 minus negative 5 is negative 1 plus 5. So that's going to be 4. 8 over 4. It's 2, just like the other one was. Okay, so it doesn't matter how you do it so long as you're consistent top and bottom. So then really quickly, why don't you pause the video, find the slope of the negative slope line segment there for me. So I'm going to pause the video, or you should pause the video, and I'll show you the answer in 3 seconds. Okay, well, if you took the first coordinate there, the 1, 2, as being your first, whatever, it doesn't even matter what we call it, first or second, who cares? I went 2 minus -4 for my rise, and then 1 minus 4 for my run. 2 minus -4 is the same as 2 plus 4, so that's 6. 1 minus 4 is -3, so that's going to be 6 over -3, it's -2. If you had done it the other way around, you would have got -6 over +3, which is still -2. So regardless, that's regardless how you calculate it, the slope's always the right sign if you do it the same way every time. Okay? But as again, as a helpful reminder, uphill is positive, downhill is negative is kind of an easy way to look at it. Okay, well here we have a vertical line. We learned in class that a horizontal line had a slope of 0. Really quickly, I just want you to calculate what the slope is for this particular line. Go. All right, so what you probably figured out is if you do the rise, 7 minus -6 is 13, and -5 minus -5 is 0. If you said the slope is 0, you are wrong. It's not 0. It's undefined. Okay? Maybe that's a little weird because we define the slope as being undefined. Isn't that kind of like an oxymoron? Anyway, speaking of morons, so this is an undefined slope because you can't divide by 0. So horizontal slope is 0, vertical slope is undefined, uphill slope is positive, downhill slope is negative. And that's kind of it, really. I can't think of anything else to do for you. And no homework questions, so just bring your homework done from yesterday and we'll all be happy, okay? See you all tomorrow.